Okay, let's start. Okay. Now, in the MATLAB program, I arranged a file. I named it cubic spline. Okay. See, for example, here, xy, we define what is x, what is y. Let me just delete that. Insert. Let me put in here a remark and a remark here. This is similar to the example you have on cubic splines. Okay, so we had points in our example. We had 4 points, 0, 1, 2, 3, and let me remove these 2 points also. And you have 0.5 to 1.5. This x and y. We determine the difference. That's h. You see here, you'll get an h. Okay, let me just run it and see how. Run cubic. Okay, cubic spline. Okay. Cubic undefined function. Okay, I should go to the path and set it as usual. Okay, add a folder, and the folder I put this in is 205, and select folder. Okay, it should operate now. Okay, now let's do it again. Okay. Okay. If you look at it here, we had 4 points. X from 0 to 3. 0, 1, 2, 3. X. Okay. So we have 3 segments. The black one is not solid. Black one solid is S0. The red one is S1, and the blue one is S2. Okay, so we have 3 segments. This one is the first derivative, smooth, as I told you before, and this linear is second derivative. For natural, this is for a natural spline. You see the second derivative at this point here is 0, and at this point second derivative at this point is 0. That's from the 2 equations. We equate second derivative. Here we equate this is the start. Okay, start of S1, start of S2, and here is end of S0, end of S1, end of S2, and at x1 and x2 here we equate the first derivative to the first derivative, and the first derivative here to the first derivative here, and also we equate second derivative with this second derivative. Okay, they are the same, and here also they are the same. Okay, so we obtain that. Now to show you how, for example, we know this is x, okay, and this is y. To find x, we say difference of x will give you a 3 by 3 matrix. It will give you a 3 elements. X, okay, x, it will give you 1, 1, 1. So difference will take this minus this, 2 minus 1, and 3 minus 2. Okay, this is the definition of the difference. So we use h to find that difference. Now n is the number of spline segments. So what is the length of x? We look at this here. What is the length of x? Length of x or y is the same. Okay, length of x, it's the same as the length of y. Okay, length of y is the same. Okay, so which means we have 4 points. So we have what? We have 3 segments, S0, S1, and S2. That's what it says here. So we define n in here as the length node. First, you know that how many segments we have? We have n segments. It means we'll be having what? 4 times n parameters. So the matrix A should be a 4n times 4n. So in our example here, we have n is 3, so it will be 12 by 12. Okay? And we can, if you want to type it, just type what is A, but it's too huge, okay? Too large, okay? Okay. So this is A. You fit the first 3, because 3 segments is the identity matrix, and here also we have 1, and here -1, and -2 times, and so on, okay? If you want to find what is S, this is S, small, okay? This is S. We have 12, S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the same example, okay? You can put it this way, organize it as this way. So these are here S1 to n. So this is the constants 0.52, and linear parameters 0.1, 1.3, 0.7, and the quadratic 0, 1.2, -1.8, and the cubic 0.4, -1, and 0.6. If you go back to your notes and find that example, you'll find these coefficients there, okay? I want you also, if you go to these notes, I have the notes, I have few corrections for you. That's in page, if we go to page, okay, page 22. In your notes, at page 22, go to the, it says there M0 and M1, that's a typical mistake, depend on the SP line, okay? And M0 and M1 equal 0 for the natural, okay? The natural. We'll find it there, okay? Correct this. This is not M1. This actually should be Mn, last one. And this one also correct it to Mn, okay? Correct, okay? Correct it in your notes. But we applied it in the example one, okay? So correct this M1 to Mn, last one, okay? And M1 to Mn, okay? So in page 22, you found that we calculated for M0 to n-1, because we know that M0 is 0 and Mn is 1. So that's the method, the first matrix, the method you learned, okay? If you check in that example, okay, you'll find the constants we have calculated using our method here is the same, okay? So I want you to practice this method, okay, for the cubic SP line. Okay, let me go and just find out this. Okay, you know how we construct A, and how we do A. We first make an A a 0, 12 by 12, or 4 times n times power n. That's just a reset A. And then we modify it. The first M 1 by the first n by n matrix is identity matrix of size n. In our case here, n is 3, so it will be 3 by 3 identity matrix. So this is the start nodes. The end nodes, study this, how we make this end nodes, okay? Here, as when I wrote h squared, h naught squared, h2 squared, h naught squared, h naught cube, okay? We start k. Here, naught, it means 1, okay? We start at 1 to n. N is the number of segments. And the number of segments in our example is 3. So 1, 2, 3. I did not start at 0 because I indexed it. So 1 means 0 in S. So H0, H1 here means H0. Okay? H2, H3 means H2, and so on. So just an index problem. So this is the start and this is the end. And then I started the first derivative equations, and we go to the second derivative equations here. And then the endpoints, second derivatives equals 0. That's the natural. Okay, endpoints. Okay, this is, it means that we have a natural speed line. Okay, then B, y1 to n, that's y0, y1, and so on. And then y2 to n plus 1, y1, y2, and so on, y3, okay? And the rest are zeros. So this is B. Then we calculate S equal inverse A times B. And for each segment, XS, just I want to plot what is for segment, each segment 1 to n. The value from the first node, this is the first node of the segment, this is k plus 1, the second node of the segment, okay? And we made a step of 0.01 to make the curves fit smoothly. Then we calculated what is y segment for each segment. What is yd1, the first derivative? What is yd2, second derivative, okay? So yd1 first derivative, yd2 second derivative. And here just for the coloring, okay? Here if k equal 1, okay, the first or 5, we choose a black color, and we choose the first derivative is a dot, and another dot for the second derivative, and so on. Just a sort of giving different colors to each segment, okay? Then we plot each segment with a line width okay? So, here we have it, okay? Here again, you plot it and you see how it looks. Exactly the same plot as you have, okay? 3 segments. Now, let's go to the same program and just, this is the first. Let me just mark this as an explanation, okay? And an explanation, and use instead of this, okay? What we have here, we added to the first 4 points, we added another 3 points, 5, 6, 8. And here the difference between first, second, third, and fourth is 1, but we jumped 3. 5 minus 3 is 2, 6 minus 5 is 1, 8 minus 6 is 2, okay? So we added different points. You can also practice adding more points, okay? Let's just do it again here, okay? Okay. Now, if you look at it here, how many points we have? Okay, 1, 2, 3, 4, 5, 6, 7 points. We had 4 and we added 3, 7 points. So we had 6 segments. The black, the red, the blue, that's 3. The green is 4. Okay, then black and red, another 2. So we have 6 segments. This here solid line is the S. This smooth curve is the first derivative. Okay, this linear okay, linear lines are the second derivatives. And you see the derivative here at this point here, okay, the end point is 0, and here also is 0. That's a natural speed lines, okay? So if we look at this, okay, let me see. If you want, for example, difference x, you see, this is the h, 1, 1, 1, 2, 1, 2, okay? So we have how many h? 6 h. For each segment, we have one h. And if you want to see the parameters organized in this way here, okay, that's the parameter. So here we have how many segments? 1, 2, 3, 4, 5, 6. 6 segments. So these are the constants of the segments. It's 0. Here is 0, 0. Here is 1, 0. It's 2, 0. It's 3, 0. It's 4, 0. And it's 5, 0. And here the linear is 0, 1. It's 0. It's 1, 1. It's 2, 1. It's 3, 1. It's 4, 1. It's 5, 1. And here the quadratic is 0, 2. It's 1, 2. It's 2, 2. It's 3, 2. 4, 2. 5, 2. And here the cubic, the last parameter. It's 0, 3. It's 1, 3. It's 2, 3. It's 3, 3. It's 4, 3. And it's 5, 3. Yes, you can organize them in this way, okay? Practice doing this. You can add another point, doesn't matter. Let me add for you, for example, 8. Let me go to, let's say 12, okay? And let's go to y. Let's go to a negative. I didn't try that, -2, and see what happens, okay? And let's just run the program again. I didn't try that, just I'm trying it with you and see what happens. That's the one, okay? And see, it works. This is, we added another point, so we have 7 segments, 1, 2, 3, 4, 5, 6, 7 segments. And the last segments is from actually 8 to 12, okay? And it's negative, you see? It goes to negative, -2 we have put it. But this is for the natural, the second derivative here is 0, and the second derivative here is 0, okay? So it works, okay? You can practice it, okay? I will end this cubic spline with you. I will upload this program for you through Watts and Blackboard, and both videos, okay, from the MATLAB and from the tablet, okay, both videos. The reason why I made this video for cubic spline, because cubic spline is very often used in several sciences, in chemistry, in mechanical, electrical. Not only that, in communications used. Not only that, it's used also in statistics and economics often. So it's very important to understand it, okay? Okay, and I will find out the other video. Don't bother too much about the marking scheme now. I will find out how we will manage it. What I want to is to practice now and understand the things. Inshallah, we will do lots of things. I will start maybe this week doing some quizzes and I will give you these quizzes, probably multiple choice questions to train yourself on it. Then I'll find with you a way, maybe in Ramadan, to during the night, for some way of assessment, maybe interviews or these things. I probably interview each one of you through the video. Okay, we'll find. Don't bother too much about this. We'll find out. What's most important now is your practice. Understand the things. Solve the assignments. Be prepared that when I ask you to send things to me, okay, they are there. Okay, now work on the assignments, practice these things, and meanwhile, I will find out this week if I can send you some quizzes to practice to make you ready for the interviews. Okay. So good luck. I will talk to you in a few days. Okay. Thank you.